Alright guys, let's do a little quick review before we start. Okay, so here is your formula that you're going to use. So A is your final result, P is your principal, 1 plus or minus R raised to the T, okay, or X. If it's, and that would be just if you are compounding annually or just it says earning interest, exponential growth, or decay. If you are, there's a word that says compound, you would use this formula, 1 plus or minus R divided by N raised to the N times T. And honestly though, you could have just used this one and put a 1 where N is, and that's the same thing, so you don't even need to know this one. The other formula that you need to know is when you see the word continuous. It is A equals P times Euler's number raised to the R times T, okay? These are the only two you really need for this section. All right, so let's look at number 19. $600 was invested, so I start with $600 in a money market account that earns 2%. Now, remember its percent is out of 100, so you divide that by 100 and you get 0.02. Question says, how much money will be in the account after 20 years? So I can use this formula or I can use this formula. I'm going to use this one. If you use this one, the N would be 1. Okay? So just know that. So your principal is $600. 1. It says investing, so I'm earning plus 0.02 raised to the 20. Alright. So you just type in the calculator. Okay. 600 parentheses 1 plus 0.02 raised to the 20 years. So in 20 years, I started off with $600, and now I will have $891.57. Round correctly, please. Okay? All right. So there you have that one. That's not bad. You made $291, and all you did was set there, starting at $600. You didn't add any more to it. Number 20. Here we go. $1,200 is invested in a money market account that earns 4.75%. Divide that by 100, so that comes out to be 0.0475. Compounded quarterly, so I'm doing that every 3 months, so that's 4 times a year. How much will it be after 40 years? All right, so I'm going to use this formula because it tells me it's compounded. Okay. So A equals 1,200, 1 plus 0.0475, compounded 4 times a year, raised to the 4 times 40. You can do dots, you could do that. All right, type it in just like you see it. 1,200, 1 plus 0.0475, 4 times a year, in parentheses, raise it up to 4 times, how many years? 40 years. Just like that. Okay? So, the interest rate, the interest keeps going in. So if you do that, by the end of 40 years, you will have $7,933.77. Should box that in. All right. And there you go. Okay? Make sure you always read the directions. The next part tells you you are assuming continuous growth or decay. That means it's going to go all the time, and the formula that goes with continuous, I think I misspelled. There should be another U there. A equals P, Euler's number, raised to the R times T. Some people say Euler, some people say Euler's. Same thing. A car depreciates, a 25,000 car depreciates, so there's your P. Depreciate at 9%. Okay, every year. Now depreciate is a negative. When will it be worth less than $10,000? So this is your A. When is a question of time. All right, so I'm going to plug it in. My final number is 10,000. I start off with 25,000. E raised to the negative 0.09 because it's depreciating. See that word? Times T. All right, you actually have to solve for this because you already know how to solve using logarithm. You guys ready? Solve for t. So I'm going to divide each side by 25,000. Did I get enough zeros? That cancel. So 10,000 divided by 25,000 comes out to be 0.4 equals e, Euler's number, raised to a negative 0.09 times t. E is a natural log, so I'm going to take natural log of both sides, and that cancels that out. So now you have natural log of 0.4 equals negative 0.09 t. Type that into your calculator and simplify it first. So remember, the symbol for natural log is right here, 0.4, just like that. Just do 4 decimal places. I will be very happy. Negative 0.9163 equals negative 0.09 t. If you do it this way, your answer is not going to be exact. It'll be close, but that's okay. All right. Continue to solve. Divide both sides by negative 0.09. And you have t left. So t answers your question of when. So divide negative 0.09. Oop, 9, not 8. A and S is the previous answer. So how long is it going to take to depreciate from 25,000 to 10,000? That's in 10.18, and don't forget your units, years. Okay, there you go. All right, let's go to number 22. Oh, my apologies. I don't know what happened there. Maybe I was moving too early. Okay, here we go. It says assume continuous, so this one's also continuous. The population of koalas in Australia is increasing by 3% each year. So that's 3 divided by 100, which is 0.03. Okay? If there are currently 10,000, so there's your beginning amount, how many will there be in March of 2030? Well, we're just going to say pretend it's April, okay? So in 2030, right now it is 2021. So what is 20 minus 2021? That's in 9 years. All right, so we got our information. Now we're going to plug it in. A equals, I start off with 10,000. Do not put a comma when you're doing the math. E, growing at 3% in 9 years. Okay? So just type that in. So guess what you have? 10,000. Count your 0. That's 1,000. There's 10. Second E. Okay? I'm sorry, you don't need to hit second. Okay. Yeah, you do. You see where EX is right here? Let me show you. See where it says E of X right here? That's one you want, and it's in blue, so you do have to hit second. Second E. And it raised it up for you, 0.03 times 9. Just like that. Okay? So that E is right here where natural log is. Push enter. So how many koalas are you going to have? 13,099 koalas in that year, in 9 years. Now, koalas, you're not going to use the decimal because you don't have half of a koala, even if you just had the head or the tail. Just letting you know. Koalas have a tail. Does koalas have a tail? Maybe they have a fluffy little tail. But anyway, you can't just have part of a koala. Either you have a koala bear or you don't. I think they have a nubby. Sorry, off track. All right, and there you have your page 5. Good luck.